Good question. The question says, given this polynomial and this factor, so x minus 1 is a linear factor of this polynomial, we want to find all of the zeros. So we're going to find all of the zeros associated with this. Well, if this is one factor, what is one such zero? What is the zero associated with x minus 1? Huh? I just got through saying I wasn't going to, and now I'm here asking y'all. I guess I'm going to ask y'all. We are going to have some back and forth. So if you want to ask a question, you can. I'm saying if this is here's what they're telling us. Yeah. They're good, Natalie. They're saying that this thing can be factored into x minus 1 times something. And that something's going to be a quadratic because this is a cubic, this is first power, there's going to be some quadratic here. So if this factor is x minus 1, the associated 0, or x-intercept, must be x equal 1. Why is that? Very good. If the factor is x minus 1, the associated 0 is x equal 1. Are y'all with me? All right, well, we can do synthetic division to find any additional factors. Grace, please close your computer. I'm going to do synthetic division. So I'm going to take that value of 1, and now I'm stripping off all the coefficients and the constants from my initial polynomial. Y'all may remember this from last year. 2, -9, 13, minus 6. If you don't have some particular power of x, you should put a 0. If it went down from x cubed immediately to x, we would put a 0 placeholder for the x squared. Does anybody have any questions where those numbers came from? All right. Now we will simply drop down this first number, and we will do this looping process. This number times this one goes here. 1 times 2 is 2, and we add. -9 plus 2 is? Good. 1 times -7 is -7. Summing gives? Okay. 1 times 6 is 6. Summing here gives? Which is a good thing because this is the remainder. Since they told us that this thing was a factor, thus this was a 0, you had to get 0 here. This number, not only is it the remainder, it is also the function value. Here's what I'm saying. If we bothered to substitute 1 in our initial function, it would pair with 0. This is the same as saying 1 pairs with 0. We knew that was going to be the case because they told us that was a factor. We knew that was a 0. Are y'all with me? So synthetic division has another name, synthetic substitution. You can use this process to just simply substitute a value in. It's very helpful whenever you don't have a calculator and you got a crazy cubic like that. Is everybody with me? Yes, Natalie?
So the question is asking us to solve for all the zeros?
Yeah. To get this new polynomial. What is this 2, -7, and 6 telling us? It has to do with this question mark here. Okay. This is the quadratic that fills in that blank. Okay. What we have done is we have divided this initial quadratic. Can y'all see the little cursor when I hover over it? Barely. This initial quadratic divided by x minus 1 yields this, 2 -7, 6. This is 2x squared minus 7x plus 6. It is simply 1 power less than the initial. Since it was a cubic here, it was a squared here. Do y'all recall this synthetic division? Okay. This thing is the question mark. Okay. So now we have this new polynomial. This new factored version, f of x is equal to x minus 1 times 2x squared minus 7x plus 6. And we could set both of these things equal to 0, but this one we've already set equal to 0. So I'm going to set this thing equal to 0. So here I go. 2x squared minus 7x plus 6 equals 0. I need to solve that equation to find the other zeros. Any suggestions? No, subtracting 6. If we want to subtract 6 from both sides, I mean, we could do that to use completing the square, but that would not be the method I would choose here. How can we solve? We could factor it. What other method do we have for solving a quadratic equation? Yes. Generally speaking, guys, that's the two methods y'all want to go for. Y'all want to go for factoring, or y'all want to go for the quadratic formula. Okay? I'm going to go quadratic formula on this one. When I go quadratic formula, the first thing I'm going to do is find the discriminant. B squared minus 4AC. And this one, in fact, tell me if it's factorable or not. Holden, what's B in this case?
7.
Close.
7. -7.
Yeah, not the X. Make sure you put that in parentheses. Kobe, what's A and C? Good. 7 squared. Y'all going to need to be able to do this by hand. 7 squared is 49. 4 times 2 is 8. 8 times 6 is 48. You got 49 minus 48. What is that? If this number is a perfect square, the original thing was factorable. We could have factored this. But we're halfway home to the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, we've already found that b squared minus 4ac part. So we have negative b, which would be 7, because b was negative 7, plus or minus the square root of, we've already found the discriminant, it's 1. What's 2 times a? Good. Equals, what's square root of 1? Lord have mercy. What is the square root of 1? 1. The square root of 1 is 1. All over 2. And so we go two ways with this. What's 7 plus 1? Divided by 2? That is one of the solutions. What's 7 minus 1? 8 divided by 2 is 4. I'm due 7 plus 1 is 8. Divided by 2 is 4. Good question. Because what was A from this right here, Rebecca? Good. And it's 2A, so 2 times 2 was a 4 there. Thank you. Forgive me. And good catch. Okay. 7 plus 1 is 8. 8 divided by 4 is 7 minus 1 is 6 divided by 4 is 3 over 2, or 1.5. These are my other zeros. X equal 2 and 3 over 2. Our original one was, what, 1? Those are all the zeros. Let me say one final thing here, okay? Now I can write this in factored form. Since these are the zeros, here are the associated factors. X minus 2, X minus 3 over 2, and X minus 1. This is the same as our original factored stuff. And this X minus 3 over 2 you could rewrite as 3X minus 2. This is has the same zero. All right. If those are the zeros, that's associated factors. Yes, Natalie? Yes, ma'am?
Why did you do the 2, bring it down, and then multiply by 1 or whatever, and then the answer to that you put to the next one?
That's the looping process of synthetic division, which we We could talk about that a little bit more, but it's just like long division. Think about how you learned to divide way back in the day. You divide, you subtracted, you brought it down, and then you multiplied. That's what this is. It's bring down, multiply. This addition is really subtraction, because technically we're dividing by x minus 1. So this addition is what used to be the division back in the day. For that looping if you definitely need to know synthetic division, so do practice that. Holden, how are you doing?
Good.
Thank you. Any other questions about number 14? Okay. I'm now looking at number 28. This would be like 29. It says, use the rational zero theorem to find all the real zeros. So 28 gives us 2x cubed, bless you, plus x squared minus 7x minus 6 is 0. All right, and we're tasked with finding all of the rational zeros. Not irrational, not square root stuff, but numbers that can be whole numbers, or numbers can be written like a fraction. All right, the rational zero theorem basically says this. Rational zero theorem. If you have some rational zeros, they will be of the form rational zeros will be of the form plus or minus p divided by plus or minus q, where p is constant and q is the leading coefficient. Grace, what do I mean by leading coefficient?
The first coefficient.
Well said, Grace. Any questions about that? What do I mean by the constant, Kobe?
The number without a variable.
Great. In this particular case? All right. Does everybody understand what P and Q are? Okay, so we're going to make a list, and this is not wonderful notation, but I'm going to say it like this. I'm going to put plus and minus outside a little set thing. I want the factors of negative 6. Well, it's 1, 2, 3, and 6. Technically, I should put the plus and minus in front of each one. Forgive me. The constant, Natalie, is the one without the variable, the 6 in this case. Okay. Divided by the factors of Q. So, Rebecca, what would be the factors of Q in this case? Good. Okay. So you're going to make a list of all those numbers. Since 1 is one of the divisors, all of those top ones are going to be one of them. 1, 2, 3, and 6. Because all those numbers divided by 1 is that. Again, plus and minus. So we already got 8. Positive 1, negative 1. Positive 2, negative 2. Positive 3, negative 3. Positive 6, negative 6. Now, you're going to take all those jokers and divide by 2. What's 1 divided by 2? Good. I'm going to write it as 1/2. What is 2 divided by 2? Well, we already have that. What is 3 divided by 2?
1 and 1.
Good. I'll write that as 3 over 2. What is 6 divided by 2? What do you note about that? We already have that. These are, if it has a rational solution, it is going to be amongst this list. It's going to be one of those jokers. Okay? Well, unfortunately, you just got to try them. All right? So we're going to do the same synthetic substitution thing and try each one of these numbers. As soon as you get one that gives you a 0, you can stop. That's the good thing about this. And when you do this in practice on a quiz or a test, I'm going to make it a situation where you don't have to dig forever. Okay? All right, so I'm going to try 1. Stripping off my coefficients, in this case it is 2, 1, -7, and -6. Any questions about that? That's from this problem. 2, 2, 1, -7, -6. Questions? 2, 1, -7, -6. All right. Now I'm performing synthetic division. Who can walk me through this? Thank you, Holden.
Bring the 2 down.
Bringing down the first number. Now,
And multiplying that by 1.
good. Yields 2.
1 plus 2 is 3.
Great. Now,
3 times 1.
good.
-7 plus 3 is -4.
Great.
-4 times 1 is -4.
Good.
Adding together -10.
Good. And that's the remainder. The key here is it needs to be 0. So you're done looking at this one, but I'm going to show what this would be if we divided. Here's what we're saying. If we divided our initial function, which is 2x cubed plus 1x squared, don't need that 1, minus 7x minus 6. If we divided it by x minus 1, if that's the 0, that's the associated factor, we would get 2x squared plus 3x minus 4, and we would get a remainder of -10. The remainder goes on top of the divisor, just like back in the day. Further, this means if we substituted 1, it would pair with -10. The point 1, -10 would lie on the graph. This synthetic substitution, synthetic division, is a powerful tool. Prior to graphing calculators, this was an algebra student's best friend. Any questions about that? So we can eject 1. Kobe, why can we eject 1? Good. Now I'm going to try 2. You knuckleheads, try 2. Put your pencil down when you're ready. If you're stuck, you can take a look at mine. Try it on your own now. What did I screw up here? Thank you, Natalie. Gosh. That Cobble kid's all right. Okay. Hopefully you got that. All right. So my initial function, this corresponds with 2x squared plus 5x plus 3. My initial function was f of x. Work. Come on now. Don't do that. F of x equals 2x cubed plus x minus 7 minus 6. How can I currently write this as a product of a linear factor and a quadratic? Thank you. Golly. Thank you very much. Love it when y'all catch my mistakes. It means you're paying attention. Man. I now know something about this cubic. It can be factored. It can be factored into something linear times something quadratic. What are those things? Good. Since our 0 was 2, the associated factor is minus 2. What's this quadratic? Great. Any questions about that? If we distributed, you would see that those are equivalent. Okay? All right. Now, we've already got the 0 associated with x minus 2. We just need the 0 associated with this one. I think this joke is factorable. 2x squared plus 5x plus 3. I'm setting this equal to 0. I'm going to try to factor it. You could use the big X method. That's kind of training wheels. I'm going to talk to you about just a different way to look at it. Think FOIL. I want to make 2x squared. That has to be 2x and x, doesn't it? If this one's a plus, we're going to get 2 of these. What multiplies to give 3? Well, 3 is prime. It has to be 3 and 1. Keep in mind, whatever we put here is going to multiply by this. I don't want that. That's going to be 6. That's more than 5. I'm going to put the 3 here and the 1 here. Here I go. 2x times x is 2x squared. 3x and 2x will be 5x. 3 and 1 is 3. Now I can set both of these equal to 0. Or x plus 1 equals 0. This clearly is x equal negative 1. Subtracting 3 from both sides. Stephen, have a good day. Appreciate your effort. The pace of this is going to be pretty fast. I am recording it so you can view it in video, but if it's too fast, just say, slow down a little, okay? Those are all of our zeros. We have 3. We have 3 zeros. We've already seen 2. Our 3 zeros are x equal 2, negative 1, and negative 3 over 2. Not coincidentally, those were all on our suspects list, weren't they? Okay. 2, negative 1, negative 3 over 2. All of those are present on our list. No. The reason for this is just to generate some possibilities. Good question. We know this. By the fundamental theorem of algebra, and that was amongst the stuff on one of the videos and in the stuff, if it is cubic, there will be 3 complex solutions, counting multiplicities. So whatever the power is, there will be that many. Yeah, sure. To the bottom? Okay. Whatever the power is, whatever the degree of the polynomial, there will be that many solutions in the complex numbers. Now, they won't always be rational like that. There might be some square roots. There might be a double root situation, but there will be basically at most that many rational solutions. Kobe?
So if we just kept doing synthetic division with all of them,
Y'all are the lucky few. Y'all are talented at math. People to your left and your right suck at math. Okay, so that's painful not in this classroom. All you guys in this classroom have strong math light bulbs. Be grateful for that. You could be one of the people that math is difficult for. Math has been easy for y'all for most of y'all's life. This is just a lot of it's a lot of process and a lot of work. So what? You'll get over it.
I think I've written more notes in the past 2 weeks than I have all last year.
My grandma. Good. Yeah, Holden, y'all are all 100% on the videos. Holden, you have done 100% of the videos. I am proud of you too, brother. Proud and a little surprised, but I knew you had it in you. Now, the real question is, are you actually studying them, or are you just gaming it? I'm not just you, but all of you. Are you actually studying the videos, attempting to learn something, and then trying an associated practice problem? Okay, this one is going to be the same process, but it's going to have some complex solutions. All right, so we'll start with that same rational root theorem. So I want to look at plus and minus p over plus and minus q. This one's much simpler. What is p in this case? Yeah, it's 1. That's nice. What is q in this case? That is wonderful. We have 1 divided by 1. That's plus and minus 1. If this one has a rational solution, it doesn't have to have a rational solution, but if it does, it's going to be 1 or negative 1. So here I go with my synthetic division for 1. That looks easy, doesn't it?
I'm going to take a guess here and say it's 1.
Well, I don't know. I mean, I don't feel like it's going to be. I feel like we're going to get a, because this is going to increase steadily, you know. 1 times 1 is 1. 1 and 1 is 2, right? This is not going to yield 0. So it must, if it exists, it must be negative 1. It's not positive 1, is it? Okay, so let's try negative 1. Ma'am? I'm listening.
The end result's going to be 4.
I did. Gosh, you guys are, man. I normally don't make this many errors, but you guys are on. I'm just saying I'm testing y'all. But the same conclusion can be drawn, though, can't it? 1 is not a 0. So I'm trying negative 1. I feel good about negative 1 because I've seen the answer in the back of the book. And it just feels like negative 1 is going to help us with this oscillation deal. Negative 1 times 1? Summing? Negative 1 times 0? Summing? Negative 1 times 1? Summing? Oh, that's good. Okay. So we're ready to rewrite our polynomial. Our initial polynomial was x cubed plus x squared plus x plus 1. We can now rewrite this as what, Avery? Good. Oh, hang on. This is x squared. This is x here. It's 0x, isn't it? So the quadratic is going to be Avery. Good. What is the linear term going to be here? If our 0, if it's x equal minus 1, if that's our 0, what's the Avery? Thank you, Kobe. X plus 1. Is everybody okay with that? All right. Now we need to set this part equal to 0. Y'all, this one is super easy because there's no x term. We can solve directly, but you could use the quadratic formula if it had an x term. So I want to solve this directly. What would be my next move? Solving for x. Why can I solve this one directly? Why am I not using the quadratic formula or factoring? What's special about this quadratic here that was different than that previous one? It has a squared term, but it doesn't have a what? An x term. It doesn't have the linear term, the bx term. If it has the squared term but no x term, you can just solve directly by taking the square root. Now taking the square root of both sides, x over here, and over here when we have the square root of a negative, we change it, we employ I. So this is I times the square root of 1, and square root of 1 is 1. So, and we should say plus and minus. Plus minus, plus minus. So this is x equal plus and minus I. So our zeros are good. Our zeros are x equal negative 1 and I and negative I. We could write this in factored form if we wished. It would be x plus 1, x minus I, and x plus I. We don't typically write with the I, we would distribute that. And if you distribute this, it would yield this thing over here. So the better factored form would be this previous thing. If you distributed these, you would get that other part over there.
I have a question. Why did you